You might think of anti-radiation missiles, also known as anti-radar missiles, but many people don't actually know what anti-radiation missiles are supposed to target. Some say they should hit search radars, some say fire control radars, and others think that simply blowing up the enemy's missile launchers would be even safer. So how do fighter jets actually conduct anti-radiation operations in reality? Today we're going to talk about the anti-radiation process for fighter jets. There's a saying that goes well: know yourself and know your enemy, and you can fight 100 battles without defeat. So to understand anti-radiation, we first need to understand what our target is. Currently, most medium and long-range air defense systems can be simply understood as consisting of three modules: missile launchers, search radars, and fire control radars. If we compare an anti-radiation mission to an event, then the enemy's search radar is like a soldier in the dark night turning on a flashlight in floodlight mode, sweeping back and forth to find your position. The fire control radar is more like the enemy finding you and focusing the flashlight's beam. But just as the enemy is about to raise their gun and shoot at you, you suddenly grab a brick and throw it at that dazzling light source. That process is called anti-radiation warfare, and the brick you throw is essentially the anti-radiation missile. So the contest between an air defense site and an anti-radiation fighter is the same. Looking at it the other way, the greatest threat to the aircraft is not the search radar, not the missile launcher, but the fire control radar. But real anti-radiation missions are not as simple as just hitting one radar. Anti-radiation missions are divided into two types. The first is called SEAD, which is generally translated into Chinese as suppressing enemy air defenses. Note that this is suppression. As long as you can make the enemy's radar afraid to turn on or temporarily ineffective, the mission is considered complete. So the most common weapons for SEAD missions are electronic jamming pods and anti-radiation missiles. If you dare to turn it on, I'll dare to hit you. If you don't turn it on, you can't do anything. That's what suppression means. The other type of anti-radiation mission is called DEAD, which means destroying enemy air defenses. Here it changes from suppression to destruction, meaning the mission is no longer just making the radar ineffective, but physically and permanently erasing the entire enemy air defense site. For example, fire control radars, search radars, missile launchers, command vehicles, and even various support vehicles can all become targets. Therefore, the weapons commonly used for DEAD missions are no longer limited to anti-radiation missiles. More often, glide-guided bombs or various bombs are used for strikes, because these weapons have larger warheads and are better suited for hard-kill targets. Once everyone understands the basics of anti-radiation, how should we actually attack the enemy's air defense site? In reality, there are three classic tactics. The first, and the most common one, is saturating the enemy's engagement channels. For example, if an air defense site can only engage 10 targets at a time, then I'll first send 20 decoys or drones to completely fill up your engagement channels. When your radars and missiles are busy intercepting these low-value targets, the fighters truly carrying out the SEAD mission can attack from behind. This method currently seems to be the simplest and most practical, and it has proven effective time and again. Recent combat experience has also shown that even the strongest air defense sites have a chance of being penetrated when faced with large numbers of suicide drones. The second is two-ship coordinated cooperation. As early as the Vietnam War, the U.S. Wild Weasel units extensively used this method. One aircraft deliberately flies into the enemy's radar detection range to lure the enemy's fire control radar to turn on, while the other aircraft is already prepared to launch missiles. The whole process is one aircraft responsible for luring the snake out of its hole, and the other responsible for precise strikes. Looking at it from today's perspective, this method carries relatively high risk. After all, it uses real people as bait. But its core tactical idea has not changed to this day. The third tactic is relying on electronic jamming, this kind of magic attack. Its principle is simple and crude. Most people basically know it, so I won't elaborate further here. Some more advanced aviation enthusiasts have even developed special methods, such as the anti-radiation offset attack method. They extend the target backward by a certain distance, deliberately making their anti-radiation missile fly a higher and longer arc. Then, After the missile acquires the radar signal at high altitude, it dives down from the sky and attacks the radar at a nearly steep angle. Some advanced enthusiasts also choose ultra-low altitude toss bombing. For example, they carry GPS-guided bombs, suddenly pull up the aircraft at an appropriate distance from the enemy, toss the bombs, and then immediately turn back and dive to ultra-low altitude to withdraw. Because toss bombing can send the bombs farther, and the brief climb can also effectively avoid enemy lock-on and missile launches, this method is also very useful against fixed radar sites. But the method I personally recommend the most is still saturating the enemy's engagement channels, because this approach is safer and more reliable in actual combat. So you'll find that the core idea of anti-radiation operations is actually the combination of SCAD and DEAD. It's just that different operational methods are used to complete these missions. I've talked about so many anti-radiation tactics today. Have you all learned them? That's all for this video. If you want to learn more about fighter jet knowledge, you can check out my other related videos. See you in the next video. Bye-bye.